You've been training for a few months, maybe longer, and something happens that nobody warned you about. You're moving more weight, plates are going up, you're hitting numbers you've never hit before, but you look in the mirror and nothing's changed. Your arms look the same, your chest looks the same, you feel like a fraud. Here's the truth: you're not a fraud, you're actually ahead of schedule. What you're experiencing is one of the most important and most misunderstood phases of training. And once you understand it, you'll never train the same way again. Today we're talking about neural adaptation, specifically why your nervous system gets stronger before your muscles even know what's happening. Let's start with a question. When you lift a weight, what's actually doing the lifting? Most people say muscles, and they're not wrong, but muscles don't fire themselves. Your brain sends a signal down through your spinal cord, through motor neurons, and into the muscle fibers. Without that signal, nothing moves. That signal, that's your neural drive. And it's more trainable than most people realize. Here's where it gets interesting. Your muscles are made up of motor units. Each motor unit is a motor neuron plus all the muscle fibers it controls. Think of it like a squad. One leader, multiple soldiers. When your brain decides to produce force, it recruits motor units. More force needed, more motor units recruited. Now here's the thing. When you're untrained, or even when you're new to a specific movement, your brain is inefficient at this. It doesn't recruit motor units in the right sequence. It doesn't fire them fast enough. And it can't sustain that recruitment under load. Training fixes this. Specifically, heavy training rewires your nervous system to recruit more motor units, recruit them faster, and keep them firing longer. This is called rate of force development, how quickly you can produce maximum force. And it's almost entirely a neural quality. That's why in the first few months of training and whenever you take a new movement seriously, your strength jumps fast. Not because your muscles grew, but because your nervous system learned. Now let's get even more precise because there are two types of muscle growth, and most people confuse them. The first is myofibrillar hypertrophy. This is growth of the actual contractile proteins inside the muscle fiber, the actin and myosin filaments that do the pulling. More myofibrils means more force production. This is dense, hard muscle. This is what you build with heavy compound work. The second is sarcoplasmic hypertrophy. This is growth in the fluid volume of the muscle cell, the energy stores, the mitochondria, the metabolic machinery. Your muscle looks bigger, it's got more endurance, but the cross-sectional force output doesn't scale the same way. Both matter, but neural adaptation happens before either. Before your muscle fibers grow, your brain learns how to use the fibers you already have. That's the strength gain without the size. So what does this actually mean for you? First, strength gains early in training are real, but they're neurological. Don't confuse them for a ceiling. When the neural adaptations plateau, and they will, that's when you need to build the actual muscle to keep progressing. That's a different stimulus. That's higher volume, more metabolic stress, more hypertrophy focused work. Second, if you're training for strength specifically, you're not just training your muscles, you are training your nervous system, and your nervous system responds differently than your muscles do. It needs lower volume, it needs higher intensity, and it needs more rest. Third, this is why technique matters so much early in training. The neural patterns you engrave in those first months, the movement patterns, the motor unit recruitment patterns, those are hard to unlearn. Train sloppily, and your nervous system locks in sloppy. Train with precision, and you build neural efficiency that compounds. If you want to deliberately develop your neural efficiency, here's what the evidence points to. Heavy compound movements. Squats, deadlifts, bench press, overhead press, rows. These recruit the most motor units across the most muscle groups. There is no substitute. Work in the 1 to 5 rep range with submaximal to near maximal loads. Somewhere between 80 and 95% of your 1 rep max. This is the zone that forces maximal motor unit recruitment without excessive metabolic fatigue. Move the bar with intent. Even on lighter sets, try to accelerate the bar as hard as possible through the concentric phase. This is called compensatory acceleration, and it trains rate of force development specifically. Take real rest. 3 to 5 minutes between heavy sets. Neural fatigue is real, and it doesn't clear in 90 seconds. If you're cutting rest short on heavy compound work, you're leaving neural adaptation on the table. And track your lifts every single session, because neural adaptation is invisible to the mirror, but it's absolutely visible in your log. That 5 pound jump on your squat, that's not luck, that's your nervous system improving, but only if you're recording it. That last point is where Swole Journal comes in. Most people have no idea how strong they're actually getting because they're not tracking with any precision. They remember roughly what they did last week. They add weight when it feels right. That's not training, that's showing up and hoping. Swole Journal turns your training log into a performance record. Every PR you hit, every rep improvement, every progression, it's all there. And when you're in a neural adaptation phase, that log is the only place you'll see it. The mirror won't show you, but your numbers will. Download Swole Journal, start logging today, make your neural gains visible. Because if you're not tracking it, you can't know it's happening. And if you don't know it's happening, you can't build on it. Train smart, track everything.